the current lecture on cloud is on some case studies, and more specifically case studies related to the available cloud platforms and including the cloud simulation platforms. So, we are going to go through some of them. So, before I start, I would like to mention that even before the adoption of cloud, whether it is for R&D purpose or whether it is for actual use in a business, it is required to assess this particular technology, the different solutions that are offered by this technology, it is required to assess. So, how can we assess? One of the ways is through simulations. So, there are different simulation platforms that are made available by different community groups. So, we can use those in order to assess how cloud is going to perform, what are the different modules, what are their implications on the overall performance of the system, and so on. So, that is a very important aspect of cloud computing. So, I will go through some of these different cloud simulation platforms, but before that I would like to make you understand some of these issues of simulation. So, first of all, the simulation tools would be required to ensure reliability, scalability and repeatability of performance evaluation. So, we have to ensure that the system is reliable even before it is used, it is scalable, and the data that we are getting that is repeatable. So, we have a repeatable environment which will give you the same or similar kind of data even if you rerun the same simulation over time. You run in at different instances of time, you have a repeatable environment which will give you similar kinds of data. So, that is very much required for performance evaluation. The simulators basically facilitate pre-deployment tests of services, and that is basically quite generic as well. I mean, not just specific to cloud, any simulator, even what a simulator does is, even before you deploy the infrastructure, the services, the platform as a whole, you need to test how it is going to work. So, this is another purpose of the simulator. And the third is, as the demand of cloud computing is growing every day, the simulators and technologies are needed to study how different features which are going to be enabled, which are going to be added additionally, how they are going to perform in the cloud environment. So, cloud simulators allow the customers to evaluate the services, to test the services and the platform at no additional cost, because no additional infrastructure is going to be taken, enabling repeatable evaluation. Repeatability I have already mentioned to you, controlling the environment, pre-detection of issues affecting performance. Pre-detection means even before actually the cloud is deployed, you want to pre-detect what are the issues that are going to be there which would be affecting the performance of the cloud environment, and that has to be done even before the deployment is going to take place. So, cloud simulator will help you do that, and designing of the countermeasures in the case of the performance degradation due to some issues or certain things going wrong. So, what are the countermeasures that have to be taken, and designing that and evaluating those aspects. Different cloud simulators that are available include CloudSim, which is probably one of the most popular simulation platforms that is available in the community. CloudAnalyst is another one. Third is GreenCloud. Next is ICANN-Cloud. The next one is CloudSim, and the last one is DCSim in this particular list. So, these are some of the cloud simulators that are available for use if you want to simulate cloud before actually deploying cloud. So, CloudSim is a simulation platform, as I said before, which has different modules, which has different classes for different cloud computing environments, including modules for data center, for modeling data centers, modules for data center, virtual machines, applications, users, network topology. So, there are different types of modules and their corresponding models that are made available. It is CloudSim is based on a Java based environment. It is written on a Java based environment that allows to examine the performance of application services. It is also possible to dynamically add and remove resources in CloudSim, and CloudSim was developed at the University of Melbourne by the team led by Professor Rajkumar Bhuiya, who is very much popular in cloud computing, and in his lab, the Clouds lab of the University of Melbourne, this CloudSim platform was developed. The advantages of CloudSim include taking care of time effectiveness. So, cloud based application implementation has to be done in minimum time with minimum effort. So, time effectiveness is one. Second thing is dealing with flexibility and applicability, supporting the use of diverse cloud environments, enabling the modeling of application services in any environment. These are the some of the advantages of CloudSim. Features of CloudSim include, I will just read from this list, and because these are quite self explanatory, I would simply read them without actually needing to explain them in further detail. So, features include various cloud computing data centers, different data center network topologies, message passing applications, virtualization of server hosts, allocation of virtual machines, user defined policies for allocation of host resources to virtual machines, energy aware computational resources, dynamic addition or removal of simulation components, and stop and resumption of simulation. So, these are some of the features that are supported by CloudSim. In the CloudSim architecture, we have different layers. The topmost layer is the user code layer, which basically presents the different machine and application specifications. The middle layer is actually the CloudSim layer, which provides the actual cloud environment and also enables modeling and simulation of cloud, and the bottommost layer is known as the core engine, core simulation engine layer, and this basically takes care of event scheduling. Event scheduling means, because we are dealing with discrete event simulation, different events like the creation of the virtual machine, the porting of the virtual machine on the host, and so on. So, these are like discrete different events. So, scheduling of the events is taken care of at the bottommost layer, the core engine layer. Creating these different entities, these different virtual machines, the data centers, etc., entity creation is also done at the core engine layer. Interaction between the different components, the clock management, because there is actually a clock class from which whatever entities you borrow, you inherit, you have to take help of the clock. That means the time will be required to be inherited, so that these different entities are time synchronized, and overall we have a clock managed solution. The top layer basically has different entities such as the users, the physical machine, the virtual machines, the applications and services, and scheduling policies. So, basically I will show you with the help of this particular figure. So, what happens is, you have this user code, and then you have the simulation specification and the scheduling policies. So, simulation specification and the the scheduling policy again breaks into two parts. One is the application configuration, which has application configuration, the cloud scenario, and the user requirement. So, this is basically that simulation specification. So, this is taken care of by these three different components: the cloud scenario, user requirement, and application configuration. The scheduling policy is taken care of by the sub components, which is basically the user broker and the data center broker. The middle layer is basically the CloudSim layer, which takes care of the creation and simulation of dedicated management interfaces, issues such as memory management, storage, bandwidth and virtual machine creation and simulation are taken care of at this layer. This particular layer helps in solving issues like host provisioning to virtual machines, application execution management and dynamic system state monitoring. It allows a cloud service provider to implement customized strategies evaluating the efficiency of different policies in virtual machine provisioning. Here is the overall CloudSim architecture. So, we have different layers in CloudSim. We have the user interface structure, the virtual machine services, cloud services, cloud resources and network. So, these are the different components of the CloudSim. So, user interface structure has two different subcomponents, the cloudlet and the virtual machine. So, cloudlet is sort of like a small physical server which will port the which will create these virtual machines. Then we have what the virtual machine services constituting the cloudlet execution of the cloudlet that is created and the virtual machine management. Then we have the cloud services comprising of virtual machine provisioning, bandwidth allocation, CPU allocation, memory allocation and storage allocation. Then we have the fourth one, which is the cloud resources component or the layer, which includes event handling, sensor management, data center and the cloud coordinator. And then we have the network layer, which takes care of the network topology and message delay calculation. So, that was the CloudSim. Another system which works on top of CloudSim is the CloudAnalyst, which is a product that was again developed by the group led by Professor Rajkumar Bhuiya. So, the CloudAnalyst is a simulation tool designed on top of CloudSim to provide a graphical user interface that will support geographically distributed large scale cloud applications. The overall purpose of CloudAnalyst is to study the behavior of such applications under different deployment configurations. So, basically this CloudAnalyst will have different metrics to take care of the performance of this cloud, the different parts of the cloud and so on. The features of CloudAnalyst include: it is easy to use due to the availability of GUI, it has high level of configurability, it has a feature of flexibility of adding different components, repeatability of experiments, graphical output provisioning with the help of charts and tables, and easy extensibility with the help of Java Swing and different other technologies. The CloudAnalyst architecture is given in front of you in the figure. So, we have two main components. One is the CloudSim extensions by offering different metrics, different extensions that will help you to analyze what is going on, how the cloud is behaving and so on, and the graphical user interface. So, this interaction with the core CloudSim and the different components, the two components of CloudAnalyst are shown in this particular figure. So, the CloudAnalyst basically comes with different components such as the GUI package for front end development, the simulation component which basically creates, executes and holds virtual machines. Then we have the user base for user traffic generation, data center controller, internet for internetworking, routing, network provisioning and so on, internet characteristics component which basically takes care of properties of the internet with respect to delay, bandwidth, throughput, etc. The VM load balancer which takes care of issues of policies for load balancing, and the cloud app service broker which takes care of entities for routing between the user base and the data center. So, why do we need GreenCloud? So that was the CloudAnalyst, and now we have another cloud simulation platform which is known as the GreenCloud. So, why do we need GreenCloud? So, in GreenCloud, so by the way, this GreenCloud was developed by a team of US and Europe Pascal Bouvry's group and Sami Ullah Khan, from the University of North Dakota, and Pascal Bouvry from the University of Luxembourg in Europe. So they together came up with this GreenCloud platform, which is again a packet level simulator which is energy aware, and that basically helps in reducing the overall energy expenses with the help of energy expenses in the adoption of cloud. So why do we need GreenCloud? The computing capacity has increased the cost and operational expenses of data centers. So energy consumption by data center is the major factor that drives the operational expenses. So what is GreenCloud? It offers operational cost. So operational cost is the energy utilized by computing and communication units within a data center, and how that is done. GreenCloud basically monitors the energy consumption of the servers, the switches, etc., and it is developed as an extension of NS2 packet level network simulator. The features of GreenCloud are listed over here. I would just read it out for your convenience. So number one feature is that it offers a user friendly graphical interface. Number two is it is open source. Next is the facility for monitoring energy consumption of network and devices. Fourth is that it supports simulation of cloud network components. Fifth is it supports monitoring of energy consumption of individual components. Next is that it enables improved power management schemes, which is very much important in the context of this particular simulator. Energy consumption monitoring and reduction is an important feature that is offered by GreenCloud, and the last feature is dynamic management and configuration of devices. So those were the simulators. Now let us talk about some real commercial and open source cloud platforms that are available for use. So some examples of open source cloud include OpenStack, CloudStack, Eucalyptus, and so on. Commercial cloud platforms include Amazon Web Services, Microsoft Azure, Google App Engine, and so on. So now let us look at the open source cloud platforms. These open source cloud platforms mostly offer infrastructure as a service, whereas the commercial ones offer, in addition to infrastructure as a service, platform as a service, software as a service, and so on a subscription basis, or that means on a payment basis. In terms of security, these security issues are implemented by the user, that means by the customer at the user end, and commercial clouds, these are implemented, the security aspects are implemented, the security components are implemented by the service provider. So here the type of the cloud is private, on premise, that means in the facility of the user the cloud will be installed and so on premise, and the commercial clouds are basically public off premise. So these are not available on the campus, in the institutional premises and so on. So these have to be available, these are made available to the public, and these have to be subscribed to over the internet. So OpenStack is one very popular form of cloud platform that can be used. So OpenStack is a collection of open source technologies that is managed by the OpenStack Foundation. It supports vastly scalable cloud system. It has pre-configured software units, different services are available for the users. It considers infrastructure as a service. So OpenStack basically supports IaaS and not SaaS or PaaS. It is easy to use because one can easily add new instances and can quickly run different cloud components. It provides a platform to create software applications and has been developed. It has developed software applications which can be used by the end users. So this is basically the schematic of OpenStack. So we have the common network component, which includes a container, a storage, and virtual machine. So this is basically the common network component. Then you have these different apps at the users apps layer, and then it also connects with the dashboard graphical interface, and the different monitoring tools are also available through the OpenStack platform. OpenStack has different components and features. I am not going to go through, but as you can see over here, they have different components for computation, networking, storage, and so on and so forth, database, etc., and they have different names for each of them: Nova, Neutron, Cinder, Glance, Keystone, Swift, Horizon, Trova, etc., These different components have their own different names. The features include allowing users to create and deploy virtual machines, allowing the setting up of cloud management environment, supporting easy horizontal scaling, that means dynamic addition and removal of instances to support more users in real time, and open source software. This is open source software which is freely accessible to anyone, along with the source code, which can be shared in order to share with the community for the deployment and use of this platform. Microsoft Azure is available on a payment basis. It is not free. It earlier it used to be known as the Windows Azure. It supports infrastructure as a service and also the platform as a service. So infrastructure as a service was also offered by OpenStack, but not platform as a service. So this paid software, Microsoft Azure, basically comes with the platform as a service in addition to the infrastructure as a service. It supports extensive set of services to quickly create, deploy and manage applications. There are many programming language support and frameworks that are available in this particular platform, the Azure platform, and it is available across a worldwide Microsoft managed data centers. So these are the different advantages of Microsoft Azure, and here the list of different services that are supported by Azure are given in front of you. We have support for computing, support for mobile services, storage services, data management, messaging, media services, content delivery. Content delivery means that something like offering different types of media, etc., through platforms like YouTube and so on. So content delivery network, developer services, management services, and machine learning support. Azure as a platform as a service, Paas platform is provided to clients to develop and deploy software. So this is very important. So when we talk about platform as a service, we are talking about some platform that is offered for the development of the software to the clients. Clients get the development platform for use on a after making the payments. So clients basically focus on application development rather than worrying about the hardware and the infrastructure. Azure is low cost, is less vulnerable to security attacks as claimed by them. Then it is easy to move on to new tools with the help of Azure. It also solves the issues related to most of the operating systems, servers and networks. Azure as infrastructure as a service, the previous one was platform as a service, and the next one is infrastructure as a service. In this particular module, it offers total control of the operating system and the application stack. It has features to access, manage and monitor the data centers, and it is ideal for the application where complete control is required. The next one, which is also quite popular, is the EC2, Amazon platform, EC2, Elastic Compute Cloud. The name says it. Actually, the advantages of Amazon EC2 is evident from the name. So a web service for users to launch, EC2 is a web service for users to launch and manage the server instances in Amazon's data center. It provides various APIs, tools and utilities. It has the facility for dynamic computation scaling in the AWS cloud, and it supports pay-per-use billing rather than making large and expensive hardware purchases. So Amazon has different Amazon EC2 has different instances. So these instances are of different types for serving different purposes, and their specific names that are given by them in EC2 are also listed over here. So in terms of the operating system, EC2 basically supports all operating systems. In terms of storage, it has temporary storage for local instance store, which is a local instance store, and also the Amazon Elastic Block Store, the EBS, and the third is the simple storage service S3. So, these are the persistent storage mechanisms that are available to in EC2. Then the automated scaling, so which is basically for horizontal scaling, where there are rules and schedules that are given, and the scaling is going to be on the basis of that. There are different available zones in the data centers that basically increases fault tolerance. So, EC2 basically comes with the concept of availability zones. So, in the availability zone, basically it is designed, the zones are designed in such a way that if there is some component that goes down, there will be some other component that is going to automatically take over. So, the zones basically at the time of creation basically ensures that such availability is there. So, that basically improves the overall fault tolerance in data centers. Features of Amazon EC2 also include firewall support for firewall rules and security. So, overall there is predefined protocol ports etc., which has source IP ranges supporting different firewall rules and security mechanisms. Elastic IP address mapping, which basically maps between the IP and the VM of user. So, what you have essentially is one pool, which is basically the IP address pool, the other one is the pool of virtual machines that can be created for the user. So, basically this elastic IP addressing will map between the IP addresses and the virtual machine and the corresponding virtual machine. Amazon CloudWatch, CPU, disk, network resource utilization monitoring, these are some of these functions of CloudWatch. Then you have the enhanced security mechanisms as features in EC2, and the last one that I would like to mention specifically is the formation, is the availability of feature for creation of virtual private clouds. So, which will basically logically separate the private clouds, not private cloud, but it is sort of like a virtual private cloud. So, I can install in my lab a virtual private cloud, which will be logically separating from the rest of the Amazon Web Services cloud, and this can be optionally connected to the user's own network. So, with this we come to the conclusion of this lecture. We have gone through two different aspects of cloud. One is the different simulation platforms that are there, CloudSim, CloudAnalyst, so on and so forth. Thereafter, we spoke about the actual cloud platforms that are available for real deployment. So, in which again there are two classes of such kind of tools. One is the open source ones. So, OpenStack by Foundation is OpenStack Foundation is an example of a open source cloud platform. The paid ones include Amazon EC2, Amazon Web Services, Microsoft Azure, and so on. So, with this we stop over here with the cloud, and also in another lecture you will be given some hands-on demos, with which you can perform some hands-on experimentation with cloud. If you have the facilities with you, you can when we go through these different steps in the next lecture, you can also perform the experiments yourselves with the adequate facilities at your end. Thank you.